In our lesson today, we're going to transition from expressions into the world of equations. An equation has an equal sign in it. Okay, that's the big difference between an expression and an equation. And there's a few things that we need to keep in mind as we work with equations. The first is a variable. Remember, we worked with variables in expressions as well, that a variable is used as a placeholder. A variable is a letter that's used as a placeholder for a number. We're going to be solving equations. And when you solve an equation, that means that you are determining the value of the variable. In expressions, I would give you the value of the variable, but your goal when you solve an equation is to determine what that value is going to be. Okay? When solving an equation, the goal is to try to isolate the variable. To isolate means to get the variable by itself. So that's what we want to do when we solve an equation. We want to isolate the variable. And to do this, we need to follow the equation's golden rule. The equation's golden rule is to keep the equation balanced. How do you keep it balanced? Well, do to one side of the equation, do to one side exactly what you did to the other side. Okay, the equal sign will split the equation up into two sides, the right and the left. Whatever you do on one side of the equal sign, you have to do the same exact thing on the other side in order to keep the equation balanced. Okay, and so that's our goal. Keep the equation balanced, isolate the variable. Can you determine the value of the variable? In the first example, we see the one-step equation y plus 4 equals 7. This is a one-step equation because it's only going to take one step to isolate our variable. Remember, the goal is to try to isolate the variable. And so we have algebra tiles, and just like we used before, the rectangle that you can see here and in the picture on your paper is the variable, and the squares represent the constants. So this green rectangle is the y, and then these four yellow squares are the plus 4. And on the other side of the equal sign, this is the positive 7. Okay, so this is where our equal sign would be. Once again, our goal is to try to get this green rectangle, the variable, all by itself. So when I'm trying to balance the equation here, okay, I have to first find where the variable is, and it's on the left side of the equal sign. But it's not alone. I have these four yellow squares here. I don't want these yellow squares to be here. So the logical thing would be to remove these four yellow squares from this left-hand side. But remember the equation's golden rule. I have to keep the equation balanced. Whatever I do on one side of the equation, I have to do on the other side. If I take away these four yellow squares on the left, I have to be able to take away four yellow squares on the right. And fortunately, there is enough over here where I can take away four yellow squares from the right-hand side. So let's go ahead and do that. I'm going to take away the four yellows that are on the left, and I'm going to take four of the yellows from the right side away. And now my variable is all alone on the left-hand side, and I can see that it has a value of 3. Okay, so let's show that in our picture. Okay, to show that I took away those yellow squares, I'm going to cross them out. 1, 2, 3, 4. Whatever I do on the left, I also have to do on the right. 1, 2, 3, 4 are gone. And now our variable is alone on the left, and it equals on the other side a positive 3. Okay, so I'm sure that many of you already knew that the answer here for y would be 3. 3 plus 4 equals 7. Let's show the algebra, however. Okay, we saw the variable on the left, but it wasn't alone. It had this positive 4 with it. So what we did to get the variable alone was subtract 4. But if we did it on the left side, we also had to do it on the right side with the 7. We had to take away 4. Bring the equal sign straight down. On the left, when we took away those four yellow squares, 4 minus 4 is 0, so all we were left with was that variable y. And on the other side, when we did 7 minus 4, that left us with 3 positives left over. So the answer here is y equals 3. One other thing that you're going to need to do when you do an equation is check your answer. Okay, when you do a check, the first thing you do is write down the original problem, which in our case said y plus 4 equals 7. And now we think that the value of y is 3, so we'll replace that in our equation. We'll make it say 3 plus 4 equals 7. Now we have some math to do on the left-hand side. We have to do 3 plus 4, which is 7. And since 7 equals 7, since the two sides are equal, our check works. And so I know that y has a value of 3. In the second example, we're going to write down the equation that we see here in the picture. Okay, so underneath the word algebra, I'm going to make my equation. I see 3 squares here that are positive, which is the number positive 3. Those were the constants. And I see a variable right here. So my variable, I'm going to use y again like I did before. So this is 3 plus the variable y. And then my equal sign on the other side, I have 5 more squares that are positive. And so my equation is going to say 3 plus y equals 5. And once again, our goal is to try to isolate this variable. We've got to get it by itself. So the equation shows that the variable is on the left-hand side, and it's not alone. It's got these 3 squares with it. We want to get rid of these 3 squares, but if I take away 3 squares on the left, I have to be able to take away 3 squares on the right. And fortunately, I have enough over here where I can do that. So let's go ahead and take away 3 squares from the left, and then we'll take away 3 squares on the right. And now we can see our variable on the left is equal to the 2 squares that are left over. So algebraically, again, our variable was on the left side of the equal sign, and there was this 3 positives that was with the variable. We took away 3 of the positives on the left, which meant we had to take away 3 positives from the right. Bring your equal sign straight down. On the left, 3 minus 3 is 0, which left us only with the variable y. And on the right, when we did 5 minus 3, that left us with 2 squares left over. So in this case, y equals 2. Now we'll set up our check. Remember, write the equation down that we started with. 3 plus y equals 5. We think that y is 2, so we'll replace y with that value. 3 plus 2 equals 5. And now we've got some math to do here on the left-hand side. When we add 3 and 2, we do get 5. 5 equals 5, so the check works. And I know right here that y has a value of 2. So we have successfully isolated the variable. In the third example, again, we're going to write down the equation that we see. So I've got my variable rectangle here. I'll stick with y that I've been using for the other examples. And now notice that my squares this time are red. They're negative. So this is y, and there's 2 negative squares here. So this is going to say y minus 2 equals, on the other side, I have 6 positives. So y minus 2 equals 6. So once again, our goal is to try to get this variable rectangle all by itself. The variable's on the left, but it's not alone. It's got these 2 red squares. And I would want to try to take away these 2 red squares to get this variable alone. But if I take away 2 red squares on the left, I have to take away 2 red squares on the right. And notice that there aren't any red squares over here. So I can't just take these 2 red squares away. So what I need to do is come up with another method. And what I'm going to do is remind myself of 0 pairs. And so if I make a 0 pair, remember that the 0 pair is a negative and a positive together. A negative 1 and a positive 1, this makes 0. Okay, so I'm going to make a second 0 pair as well. There we are. So I've got 2 0 pairs here. This is 0 and this is 0 as well. Y plus 0 is just y. Okay, so I technically don't need this as part of my picture, but let's remember what we did. We started by actually adding in 2 positives into the picture in order to create those 0 pairs. So if I added 2 positives on the left-hand side to keep my equation balanced, I'm also going to add 2 more yellow squares on the right-hand side. So there's my other 2 yellow squares on the right-hand side. So I added 2 here. I now added 2 over here on the right-hand side. And again, if this is a 0 here, I don't need it in my picture. Y plus 0 is the same as just having y on this left-hand side. So now I can see that my variable's alone, and it equals a value of 8. Okay, so in our picture up above, we're going to draw in the squares that we added. We added 2 positives on the left, and we'll put those plus signs in there. And then we added 2 positives on the right. And again, we'll put our positive symbols in there. Algebraically, what we had to do, we added 2 on the left. So underneath of -2, I'm going to write +2. And then we added 2 on the right. Bring the equal sign down. -2 plus 2, that's your 0 pair, which left you only with the variable y. And 6 plus 2 equals 8. Now we'll go ahead and do our check. Remember to write down the original equation. Y minus 2 equals 6. We think y is 8, so we'll replace y with 8. 8 minus 2 equals 6. And now we have some math to do here on the left side. 8 minus 2 is 6. Since 6 equals 6, the equation checks, and I know that y had a value of 8. In example 4, we have the equation x minus 4 equals -3. This is my variable x. These are 4 negative squares, which is -4, and then 3 more negative squares, that's our -3. We need to get x all by itself, all right? So I would want to take away these 4 negative squares, but I can't do that over here because there's only 3 negative squares. So again, I'm going to have to create my 0 pairs. Since I have 4 negative squares on the left, I need 4 positive squares with them to make the 0 pairs. So here are my 4 positive squares, which are going to make my 0 pairs. And since I added 4 positives on the left, I need to add 4 positives on the right. So I'll add 1, 2, 3, and a 4th positive on the right-hand side. And now, since these are all 0 pairs here on the left-hand side, I'm going to remove them. Okay, so those zeros are gone. And I actually have 3 0 pairs here on the right side. Here's 1, 2, and a 3rd 0 pair. I can take away all of the 0 pairs on both sides. So those are gone. And now our variable's alone, and it equals this one little square that's left over. Okay, so let's do this algebraically. The equation said x minus 4 equals -3. Okay, x minus 4 equals -3. And what we did to get this variable alone was add 4 positives on the left-hand side. We added 4 positives on the left. So then we added 4 positives on the right. And now when we do the math, on the left, the -4 plus 4 made the 0 pair, leaving us with the variable x. And on the other side, when we had -3 and added 4, all right, that left us with 1 positive left over. So x equals 1. Doing our check, x minus 4 equals -3. Replace x with 1. 1 minus 4 equals -3. And here on the left, these have different signs, +1 and -4. So we would subtract. 4 minus 1 is 3. And it's going to be negative because the -4 has the bigger absolute value. So -3 equals -3. And I know that x has a value of 1. In example 5, the equation says 3x equals 9. Okay, so we're going to draw that picture in there. To draw 3 x's, remember that's going to be 3 rectangles. So I'm going to draw 1, 2, 3 rectangles, and they're positive, so I'll put a positive symbol in each one of those. And then on the other side, I need a constant of 9, which is going to be 9 squares. So let's go ahead and draw in 9 squares. And again, they're all going to be positive, so I'll put positive symbols inside of all of those. And so there's what the picture looks like for the equation 3x equals 9, okay? Well, our goal is to try to get the variables all alone, and if you notice here on the left-hand side, they are. All these variables are by themselves. There are no constants over here. So we have to figure out now, okay, if 3 variables, 3x's equals 9, our ultimate goal is to figure out, well, how much is just one of these x's? And so what I'm going to do is try to break this left side into groups where there's only going to be one x. So I'm going to break it into 1, 2, 3 groups. Okay, so if I broke the left side into 3 groups, I'm also going to break the right side into 3 groups. Okay, there's 9 here, so that means in each group there's going to be 3. So there's one group, a second group, and a third group. And now I can match it up. One variable has a value of 3. One variable equals 3. One variable equals 3. Algebraically, the equation said 3x equals 9. And when we broke this up into 3 groups on each side, what we actually did was divide by 3. So on the left, we divided into 3 equal groups. And then on the right, we divided into 3 equal groups. On the left-hand side, 3x divided by 3 is 1x, which is the same as x. And on the right, 9 divided by 3 is 3. So our answer here, x equals 3. To do our check, if it said 3x equals 9, replace x with its value of 3. So this would say 3 times 3 equals 9. And when you do 3 times 3, well, indeed, you do get 9. 9 equals 9. So I know that x had a value equal to 3. In question 6, I've already drawn the picture, so I'm going to encourage you to pause the video and draw this picture as well. Our goal is to try to figure out the value of 1g, okay? You can see our variables are already alone here on the left-hand side. We have 2g equals on the other side, -8. There's 8 negative squares there, okay? Since I have 2g's and I want to get the value of 1g, I'm going to divide this into 2 equal groups. So I'm going to have 1g in each group. Since I divided the left into 2 groups, I'll divide the right into 2 groups. And in each group, you're going to end up with a -4. So each variable should be equal to -4. So the first thing we did on the left, we took 2g and divided it into 2 equal groups. Then we took the -8 and divided it into 2 equal groups. And when we did that, 2g divided by 2 is 1g, which is the same as g. -8 divided by 2 is -4. So for our check, if 2g equals -8, and we think that g is -4, we would have to do 2 times -4, which gives us -8. So -8 equals -8, and I know that the value of the variable in this example is -4. So at this point in the lesson, I'm hoping you're starting to notice a pattern here, okay? What are we really doing in each of these examples, okay? So if the number is being added to the variable, like in this example, it says n plus 15, all right? Then what you need to do in order to isolate the variable is to subtract the number, okay? Since we're adding 15 to this variable, to get the variable alone, we have to subtract by 15 in order to get n all by itself. And remember, what you do to one side, you would do to the other side. Okay, 15 minus 15 is 0, leaving us with n on the left. 20 minus 15 is 5. So the answer here for n would be equal to 5. If the number is being added to the variable, then you subtract that number. If the number is already being subtracted from the variable, like up here, n is being subtracted by 15, well, to get the variable alone, you're going to have to add the number. Okay, so if it's n minus 15, to get n all alone, I'm going to add 15. And if I do it on the left, I'm going to do it here on the right, add 15 to each side. -15 plus 15 is our zero pair, which would leave us with n on the left, and 20 plus 15 would equal 35. All right. If the number is multiplying the variable, like in this third example, 15 times n equals 30. To get the value of n, what you would have to do is divide by the number. So I would divide 15n by 15, and I would have to do it to the other side as well. Okay, 15n divided by 15 is 1n, which is the same as just plain n. 1n and n are the same. 30 divided by 15 equals 2. So the value of n in this example would be equal to 2. So you're always doing the inverse operation. If the number was added, subtract by that number. If the number was being subtracted, add that number. If the number was multiplying the variable, divide by that number to get the variable alone. So there's one more case that we're going to look at. If the number is dividing the variable, then you will need to multiply by that number in order to isolate the variable. In question number 4, 4 is multiplying n. 4 times n equals 228. Since the number was multiplying the variable, then you're going to divide by that number. So I'm going to divide by 4 on the left, and I also need to do that on the right to keep it balanced. 4n divided by 4 is going to be our 1n. And if you divided 228 by 4, if you punch that into your calculator, you would end up with an answer of 57. N equals 57. In question number 5, this says n divided by 4 equals 5. The number is dividing the variable, so you'll need to multiply by that number to get the variable alone. So on the left-hand side, I'm going to multiply by 4, and I'm going to make that 4 over 1. And on the right-hand side, I'm also going to multiply by 4. Okay, and when I do this on the left-hand side, all right, these 4's actually simplify down to 1's. So this is 1 over 1 times n over 1, which is just n, and 5 times 4 equals 20. Okay, and you can check to make sure that that works. N divided by 4 equals 5. We think n is 20 divided by 4 equals 5. And if you did 20 divided by 4, you indeed would get 5. 5 equals 5, so n equals 20. In the last example, n is being divided by 3, and the answer is 4. Since the number 3 is dividing the variable, then you will multiply by 3 on both sides. So on the left, I'll multiply by 3 over 1, which is the same on the right as multiplying by 3. These 3's are going to simplify down to 1's. 1 over 1 times n over 1, again, is just n. And 4 times 3 equals 12. So remember, to isolate the variable, you always need to do the inverse operation.